Hello and welcome to the Safer Soccer Academy community on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. So in this video, we are looking at June 2020 Advanced Level Physics Paper 2, Section A, Question 3. And before I continue, I would like you to subscribe to the channel and activate the notification bell to not miss any of our videos uploaded. And if you want other videos like this, you can go down, you can just scroll up on the channel and then you'll see many videos that I've already uploaded. Now the question reads, figure 2 shows part of a system used to eject and accelerate electrons. The figures are there. A, state the phenomenon of emission of electrons from a sufficiently heated metal surface. B, determine the speed with which the electrons leave the anode. C, upon leaving the anode, the electrons enter into a region of cross-magnetic and electric fields as shown in figure 3. If the intensity of the electric field is 7.5 times 10 to the 4 volt per meter, calculate the flux density of the magnetic field if the electron pass through the cross fields undeflected as shown in figure 3, as you can see there. Okay, let's go directly to the solution. And now, as a reminder, being a science student, more specifically a physics student, you need to be able to read questions twice. When you see a question, don't just jump directly into the question, even if you know it as well. You read the question once to know the information that I've asked to you and what you are required to solve, and then the second time to collect your data. There. So A, it is simply thermionic emission because it asks for the phenomenon from which electron can be emitted from a metal from a sufficiently heated metal surface. So just the presence of heated metal surface gives rise to a thermionic emission. So B, we are calculating the velocity with which the electron leaves the anode. That one is in figure 2, if you can remember well. So from EV is equals to half ME V squared. Now, why am I using this formula? I'm using the formula of kinetic energy because if there is velocity, means that there is a kinetic energy. And the mass that we're using there is the mass of the substance that is used, which is an electron. So we are using the mass of an electron and the charge of the electron. That capital V there stands for the voltage, where E is equals to 1.6 times 10 to the negative 19. ME is equals to 9.1 times 10 to the power negative 31 kilograms. V, that is capital V, is 2000 volt, is the voltage given. So we make V the subject of the formula. We get V is equals to the square root of 2 EV all over ME, and we just replace our data that we have there to get the answer as 2.65 times 10 to the 7 meters per second, and that is the value of the velocity. C, calculating the magnetic flux density. So the particle passes through undeflected, hence the magnetic force is equal to the electric force. So if the particle passes through undeflected, it means that the magnetic force is equal to the electric force because it's a region of cross magnetic and electric field. So a particle comes in and passes in undeflected, means that both forces are equal. That is, BEV is equal to EV, E times E. Now B there stands for the magnetic flux density. Small e stands for the charge of the electron or the particle. V stands for the velocity that we have previously calculated, and capital E stands for the electric field intensity given in the question. So making B the subject of the formula, we have that B is equal to capital E all over V, and we just replace our data given. E was given in the question and then V was calculated in B above. So we have our B as 2.3 times 10 to the negative 3 Tesla. So guys, we have come to the end of this video, and I would like you once again to subscribe to the channel and activate the notification bell to not miss any of our videos uploaded. And I also invite you to share the video to any friend in the advanced level so that it should be able to also attain academic excellence. And not forgetting that in science, consistency is the key.